All right, class, welcome back. We're going to start in with some 8th grade algebra now, but don't be afraid. We're still going to call back on all of our previous skills. We're going to look at, we're going to take it to the next level. We're not just going to do 2-step or 3-step equations anymore. We're going to focus on ones with variables on both sides of the equation. So here's a little example problem.
Check out these new cars. For big ticket items like these, sales reps usually make a base salary, plus they get a commission, or a percentage based on the final sale price. But if you want to sell cool cars like these, you better be ready to use some math. Let's say you're trying to figure out which of 2 dealerships you should work for. Dealer 1 pays a monthly salary of $3,500, plus a commission of $150 for every car sold. Dealership 2 pays a monthly salary of $3,000 and a commission of $200. How do you choose where you should take a job? You can use an equation to figure out how many cars you'd have to sell each month for the salaries to be even. In this case, if you sell 10 cars in a month, it doesn't matter where you took a job because you'd make the same amount of money. But if you think you could sell more than 10, take the job at dealership 2 to take advantage of that higher commission. And that's another reason math matters.
Okay, go ahead and pause the video and add this to your table of contents. Again, we're going to focus on solving equations with variables on both sides. So in the video we watched a car example. Here's another example. For $30, a theater will sell you a discount card that'll let you buy tickets for $5.50 each. Tickets normally cost $8. How many discount tickets will you have to buy to equal the cost of buying tickets at the regular price? So here's another example of a situation that can be written with an equation that has a variable on both sides. So like here's $30 plus $5.50 each ticket. The x is representing the tickets equals 8x. So what's different about this? Hopefully you can see that, like I said already, there's an x on both sides. How will we ever come up with a way to solve things with variables on both sides? So don't freak out. I got some algebra tile examples for you. All right, so here's 3x plus 1 equals x plus 5. So again, my goal is to try to get x by itself. So I can't solve it the way it is right now. I need to get all my x's to one side. I can't just take this x and put it on that side, okay? Because I have to do the same thing on both sides. If I take the x and move it over here, that's taking away 1x over here and adding 1x over there, and that's not balanced. But I do want to get all my x's on one side. So how can I get rid of this x? I can take an x away, and since I did that on one side, I got to do it on the other. And now I just have myself a 2-step equation. So again, I want to get x's by themselves. So again, I'm not going to just slide that over there, because that would be minusing 1 over here and adding 1 over there. So if I want to get rid of this 1, I have to take it away. Take away on that side to be balanced. And then I just solve like normal. I don't care about 2x. I want to find out what 1x is equal. So I'm going to split it into 2 piles. And I see that x equals 2. All right, here's another example. I have 2x plus 7 equals 3x plus 4. Again, I can't just take these guys and just smush them over there. Okay. But it is definitely... so I want to get rid of one of these piles of x's, and I want you to think to yourself, is it easier for me to minus 2x from both sides or minus 3x from both sides? If I minus 2x from both sides, I'm left with 1x over there, and that's pretty cool. If I try to minus 3x from both sides, I can't. And I'd end up with a negative x situation over there, which I don't really want. So I'm going to go with my original plan of minusing 2x from both sides. And then I got myself a 1-step equation. I want to isolate my variable. I'm going to get rid of these 4 1s. Whatever I do on one side, I'm going to do on the other. So I'm going to get rid of these 4 1s, and I see that x equals 3. So in those last examples, what was our first step? It was to get the x's on one side of the equation by subtracting the smaller coefficient from each side. So what I mean by that is the smaller pile of x's. In this problem, I started by minusing 2x from both sides. And in this problem, I started by minusing x from both sides. So I'm going to get rid of the smaller pile of x's, i.e. I'm going to subtract the smaller coefficient of x from both sides. All right, so here's another example. I have x minus 4 equals 2 plus 2x. So I'm going to use that step. I'm going to get rid of the smaller pile of x's. So I'm going to minus 1x from both sides. Okay, and then I want to isolate x. I need to get rid of these two yellows, but I can't just take them away because I can't keep it balanced that way. So I'm going to add 2 reds to both sides. This business cancels out, and I'm left with x equals negative 6. Here's another quick example. I have 2x plus 5 equals negative 1 plus 4x. So I'm going to do that first step again. I'm going to get rid of 2 x's from each side. And then what's my next step? I'm going to isolate my variables. Now I'm just down to like what I did with two-step equations. I can't just slide that red out of there, so I'm going to add 1 to both sides to cancel that out. And I'm left with 2x equals 6. And again, I don't care about 2 x's, I care about 1x. So I'm going to make 2 piles on both sides, and I can see that x equals 3. All right, so in all of those examples, the second step was to get all the 1's on the other side of the equation away from the x's. And I did that by minusing or adding the 1's to cancel them out. All right, now let's mix in a little bit more red and see what happens. So I have negative 3x plus 4 equals negative 2x minus 1. So again, what's my smallest pile of x's? It can appear that this is my smallest pile of x's, and but what actually has a smaller value? Negative 3x or negative 2x? Negative 3x actually has a smaller value. If you do end up adding 3 yellows to this side to, adding 2 yellows to this side to cancel it out because you're like, oh, okay, well, that's a smaller pile of x's. You're really not doing anything wrong, but what you'll end up with is negative x, and then you end up having to divide by negative 1, which is not the end of the world. You still get the same answer, but just trust me on this. The easiest thing to do is to go with the one with the smaller value. So negative 3x has a smaller value, so I'm going to go ahead and add 3 yellows to this side to cancel it out. Whatever I do on one side, I'm going to do on the other. I'm going to get my 0 pairs out of there. And then my second step is to get all the 1's on the other side away from the x's. So again, I'm going to cancel out that minus 1 by adding e plus 1. Get my 0 pairs out of there, and I see that x equals 5. I think that's good enough. All right, so all those problems, we finished them up the same way we did two-step equations. So just to recap, we added or subtracted to get all the variables on one side. We added or subtracted to get all the constants or 1's on the other side. And then we multiplied or divided to get the variable by itself. Go ahead and hit pause, copy down these steps. And again, you're going to want to use that tip. If you don't use this, you're not going to get it wrong, but this just makes the problems, it takes one step away for you, and I'm just trying to make your life easier. So get rid of the smallest coefficient first, and then it's just normal two-step equation business. All right, let's do a couple of example problems, shall we? So it's so nice, we're going to write it twice. And let's go ahead and get to work. All right, we're still going to box and circle, because, boxing and circle is everything. All right, so our first step is to get all the x's, all our variables to one side. Remember, we're going to work our steps here. So we're going to get all our variables to one side. We're going to get rid of the smallest coefficient first. So our smallest pile of x's is 1x. So we're going to get rid of this x by minusing x on both sides. Draw our little summing line here. I get 3x equals negative 6, and then I'm down to just a one-step equation. I'm going to divide by 3 on both sides. And I'm going to get that x equals negative 2. It's pretty easy to do checks on these things. Just sub in negative 2 back in. 4 times negative 2 equals negative 2 minus 6. 4 times negative 2 is negative 8. Negative 2 minus 6 is also negative 8. Boom, got it right. Okay, let's try another one. Again, write it twice. I'm going to box and circle this thing. And I'm going to remember that my first step is to get all the coefficients to one side, my squares here, my boxes, and I'm going to move the smallest pile of x. So this is my smallest pile of x. So I'm going to move that first. Cancels out over there. I end up with x minus 5 over here, and I have negative 7 left over. I'm going to get rid of that minus 5 by adding 5 to both sides. And then I'm left with x equals -2. Again, you can do a quick little check here. You can go 2 times -2 minus 5 equals -2 minus 7. 2 times -2 is -4. -4 minus 5 equals -9, and that is true. All right, I think that's good enough for now. I want you to go ahead and pause and just try one. Just one little problem. Give it a swing. See if you figured it out. And that's it for today. So make sure to look over the steps and try that one problem. Don't pretend like it didn't happen. And come with your questions tomorrow. I'll give you a participation point if you ask a question. But, you know, not just a random question. Anyways, get a good night's sleep, and I will see you in class tomorrow.